Awesome. Yeah, no, thank you, Ron. Thank you, everybody, for joining us today. Yeah, it's our first kickoff for 2023. Can't believe it's already almost mid-February. Absolutely insane. My name's Corbin Davis, Director of Energy for OneSource Sonepar Energy as well. What we're going to talk today is a lot of EV charging focus. Talk about like available, create the awareness that there are a lot of available incentives that are out there for many different layers, maybe many different entities as well that help reduce the investment costs into EV charging. And then later on in the presentation, we're going to get more towards the technical side on what kind of chargers are available. Level 2s, what are level 2s? What are level 3s? What are the different connector types that unfortunately now with the EV charging market's been it's very new and fast evolving. There's not really standard connector types for the fast charging market for specific cars and specific vehicles. We're getting to that standardization level, but we're not quite there yet. So to kick it off, I just want to say there's misconceptions as well too, where it's like, hey, I have these charging stations. Like I want to do this clean green energy. Like I'm going to be all sustainable. I want these charging stations to be powered by solar energy. So to dive into that, so we're going to look at actually the semantics and how we design a solar system to basically incorporate energy for EV charging stations. So let's say that we have our gas stations. We have gas stations all around us. And let's say we have 5 to 10 to 15 basically dispensers, every gas station that we have on your local corners. So in order for that to retrofit to become EV charging, we have to adapt to around 350 kilowatts, 175 kilowatts, to get the right charging speed so that we're not just waiting, having long dwell times to charge our cars. So around 175, 350 kilowatt charging station, our cars will charge within a 5 to 20 minute window. So let's just say 350 kilowatts for one charging station. That's going to help us charge our car for 5 to 10 minute window. So I need 1 acre of land to produce 800 kilowatts. That's for solar energy, to provide the right energy demand for these fast chargers. So basically with 1 acre of solar power, I can have 2 fast chargers. So I've heard a lot, I've been approached a lot with all these, these ideas of, hey, let's see how we can try to do solar and power these fast chargers. It's like, maybe you know something that I don't know, but I can't really see it being totally reality. So there's a lot of there's a lot of things that are still developing and the market's still evolving. Also, too, like these fast chargers, a lot of things that can be forgotten as well is what does the electrical infrastructure look like? So, of course, what size wire, what size switch gear? Do I have enough electrical capacity to be able to charge these charging stations? So that's one of the things that's not like the sexy talk about okay, hey, EV charging stations, fast chargers, awesome. But then the power demand. What is the power demand? Can my utility provide me that power demand? Do I have available power demand and capacity that's available? So those are really huge things that sometimes kind of get overlooked because it's not the charging station itself; it's actually the infrastructure behind it that can actually help bring these power demands in these different the right power to our stations that need essentially to have these stations up and running. Goals and sustainability can be cut up and chopped into so many different ways. But as we know, if we're able to retrofit our power sources and our power demands, of course, by providing clean green energy by solar and batteries, a lot of our corporations and a lot of our sustainability goals can almost be achieved from 90 to 100%. And those are one of the most important topics. And so back to my almost previous point about trying to provide solar energy for EV charging stations, EV charging stations are strictly demanding power. So they're not so solar is offsetting power. I'm no longer demanding power from utility. I'm actually generating power. However, with EV chargers, what's generating the power? How are you getting that electricity out of that charging station? Some power has to be fed to it. So also to keep in really the great thing to keep in mind is that EV chargers are power consumers. So we do have sustainability goals. If we're trying to reduce our carbon footprint at our facilities or within our corporations, EV chargings help our reduction on our fuel because it's like electricity instead of fossil fuel burning fuels, but also how do we get that fuel? So either we can basically design, a lot of it has to be demanded from the grid to get that power. Depending on the different charging stations, we could get solar, but that's going to be on a much smaller scale to provide our solar power needs. And as Ron mentioned, there's so much money that is out there, over $1.2 trillion, so many different grants and incentives. And we've been following this very closely since the 1.2 trillion, infrastructure bill has been released, and it's tricky because there's so many different programs that are preparing to get themselves ready to go. And it's hard to basically have the awareness to know what is exactly out there, but also the application windows are tight and very small. So there's millions and even billions of dollars available for these type of projects, but it's very important to have a trusted partner, because you could be planning for an EV charging project or an investment project. And I want to get 80% of the federal funding. However, you may only have a month window to submit and apply. And that month all of a sudden just comes out of nowhere, and all of a sudden it's like, oh shoot, where did this come from? We're going to say ourselves, we're fully engaged with the government, the federal programs, the local utilities, state energy commissions, to ensure that we're up to date for our customers. If our customers are interested to work with us on essentially for our EV charging project, but also to manage that, to ensure that we can get paid for our projects and for our ideas, and get majority of those projects funded.
Hey, Corbin, just two things. I just want to emphasize, I put in the Q&A, all the slides will be available for download. Give me a day or two. All the videos will also be available off our YouTube channel on demand. One of the things, Casey, who's one of our facility managers in attendance, was questioning, is there a best practice for facility managers who all are getting pressure to add EV to their portfolios, to their parking lots? What percentage? It's not like this is net zero. I can tell you, Casey, I'm going to have you follow up directly with Corbin. Your own particular EV deployment is going to be dependent on the money you get. What's available in California may be different from what's available in Nevada. It depends on your facility. Maybe you've got lots of excess power. Maybe you've got the ability to put in more batteries to augment it. Maybe though you're very tight. Maybe you've only got a parking garage in a closed structure, where the challenges of placing EV chargers and getting access to the public grid may limit it. So for any of you out there, I bet that Corbin will answer this the same way. He and his team can absolutely work with you to lay out based on your particular footprint, based on available excess real estate in there, based on the utility you're working with. It's not one size fits all. You need to get it customized. Corbin can help you. I'll set that up. Casey, if you could put your email in the chat, I'll make sure I follow up with you and Corbin while Corbin continues his talk.
Awesome. Yeah, and it is a great question. And that's where, like, in the energy world, like, it's very unique, because every customer has a different circumstance in how they use their energy. And as Ron mentioned, we all have different electrical capacities at our facility. How much space of it available do we have? Do we have extra space on the transformer? Do we not have extra space on the transformer? But also, what markets are we living in? What is the EV adoption rates in our specific markets? So there's a lot that can go into place, because, of course, the investment in the charging station projects, it's not just the charging stations themselves. Trenching, we have to dig into the concrete. We got to run wire wherever we want the charging station and bring that back to the electrical panel. So there's a lot of variables that go into it, and that's kind of where, unfortunately, it can't just be like, cut and dry for a one size fits all for the different applications, because everyone's electrical infrastructure is different, and their goals are different, and charging adoption rates in different states are different. And so that's kind of, here's more of like I'll say somewhat of a pitch of what our company can help provide. We absolutely help our customers, kind of like I just kind of mentioned in that segue, achieve our sustainability benchmarks, give the proper advice, consulting, and also the right recommendations to ensure that we have exactly what we need. And of course, one of the main things that we do not want to do is to essentially, because charging stations can get very, very expensive, and sometimes we don't need to spend tens, even hundreds of thousands more if we don't necessarily need to on these type of investments. And of course, the sustainability model, as we know, it's a very norm, community focused, societal focused type of thing of becoming more sustainable. There's so much benefit that comes with that. As I mentioned before, so here's kind of like a lot of infrastructure solutions that can be done for any type of like critical loads that are not necessarily available. If we have capacity issues, here's a couple of products that can help. A lot of it that we're seeing too, along with the federal grant programs, is batteries. So battery storage, essentially, because again, I need, like, for, let's just say 350 kilowatts, 175 kilowatts is one charging station. So if I have 5 or 10 of them, think about that. Let's keep it easy. If it's 300 times 10, that's 3 megawatts. That's a lot of power that they needed to demand just at one location. So battery storage essentially can have that power already available. So kind of like gas tanks, right? Like we go to like propane tanks and, or propane tanks. Our gas tanks at like local gas stations where we have these gas reserves under the ground where we basically park our cars. That we can essentially retrofit that, add battery storage to have that available power for these type of applications. And so in this presentation, I'm going a little bit about who we are, who is OneSource, who is Sonepar, introduction to EV charging, and of course, on a level 2 and a level 3 aspect. What do the level 2s look like? What is the fast charger market? And just kind of briefly go over the software and the values, and then the components of the software, and what does the software provide? What does that look like? Because a lot of charging stations, it is a dance of having a smart communication system, a software that we can manage these systems and also protect our systems from any unwanted users to use our charging stations. We kind of OneSource Sonepar Energy with a state-of-the-art energy department. We've been lucky enough to win a couple of awards for creating a one-stop shop. So a lot of it is full design, full consulting on energy projects. If it falls in the realm of solar, battery storage, carports, EV charging, financing, we like to think we have all the solutions that are available for an energy project. And we've been, like was mentioned before, been lucky enough to win a couple of awards, and we've been reaching out to write a couple of articles for some magazines to create some credibility, I guess, for us, but for what we have, what we're doing in the marketplace to help more faster adoption rates in this energy marketplace. So our core, who we are, we're a $31 billion company now. So we're the largest distributor in the world, and so we can do business all over the United States, all over North America, and all over the world, serving we can almost serve almost all the markets that are available. Past projects, we've done projects with many different verticals. On the EV, I know this is more EV charging focused. So we have done a lot of transportation authorities. So a lot of, at least in our area, I live in Huntington Beach, California. And so a lot of our transportation authorities are actually retrofitting a lot of their city buses and a lot of their fleets to become electric. So we've done a lot of work with a couple of transportation authority contracts where we're actually going in there and designing specific charging stations to actually a 6-minute interval to know exactly like, okay, so we charge with a 150 kilowatt fast charger. We can get this bus fully charged in 2 hours and 56 minutes. Now we can strategically be aware of our routes and how long and sustainable our routes can go based upon having the available fuel sources that are needed. Universities, a lot of UC universities out here. Let's say a lot of semi trucks out in the Midwest. They're building supply chain vehicles that are going to be able to, of course, do cross the country trucking and having those be electric. So we've done a couple of electric charging station projects with them. So there's so many different opportunities that are available, and we've been lucky enough to have some great experience. Real quick, a lot of the stuff that we do, we're full scale. So I know this is a more EV charging focused conversation, but we can have this kind of conversation with many different types of products that we can offer. Battery storage, financing, carports, of course, the grant writing, rebates, consulting, solar system, microgrids. We essentially think that at least right now, the energy world changes all the time, but at least right now we're pretty set for what we have. So here's more on the energy side: one-stop shop design, ecological analysis, financial analysis, economic analysis, provide detailed economic proposals. And after this, we'll have engineering for this type of project. And of course, have our labor partners come in to perform a energy project at a site. Okay, this is more related to EV charging. We can do full consulting, design, and grant writing. So that one question that we had about, facility managers, what are the recommended charging stations do I need for my facility? I have this business, so what is the best charging station power outputs? What are the available rebates, grants, and incentives that are out there? What is the budgets? What are my costs going to be? What is the labor cost? What is the material cost? What are the rebates and incentives in my local area? What are my rebates and incentives in my statewide area? What are they in our national area? So we will be able to help and work and provide that information if we would like to essentially work together. And that's part of our consulting and grant writing piece. And that's where, on that note, so I know we all want to learn about rebates, grants, incentives. There's so many out there, and it depends on where the project is. So different utilities or different cities will offer their own specific packages. And so knowing looking into those local programs, there's local programs. And of course, then it goes all the way into the statewide programs and then federal programs. A lot of these programs you can stack. So it's like, I can have federal funding. So say I can get 80% of federal funding, but I still can stack my local rebates and grants and my local rebates and incentives along with the grant that I've received. We normally can't stack multiple. If it's a local utility, we can't stack multiple different local utility programs. But if one's a local utility and one's a federal, we can stack. So that's what's pretty cool and unique about an incentive benefit. So it's like, if we find the right projects, find the right incentives that are out there, and we get them all submitted on at the right time frames, we can almost get a lot of our projects covered, which is pretty cool. And so kind of what that looks like as well. So it's kind of on a baseline view. We can do a full scale market analysis. So of course, to that question, what is our adoption rates? What does it look like what is the perception of my area? And what is the growth of the community that are retrofitting to become EV charging? What are my goals? Am I trying to have investment properties that I want to show that I have EV charging stations? So I want to think that I'm ahead of the curve, that I have a sustainable forward thinking company for people that want to work here or want to live here. And so for us too, we'll offer the grant rebate benefit identifications. And of course, there's an analysis as well. So just because there's available rebates, grants, and incentives, they're not going to be available for that long, to be quite frank. And so a project dedicated to just because the designs are very important on what stations that you're trying to do. Because some programs are only available for specific power output charging stations, and they're compared to others. So sometimes, let's go back to that one question. One facility, the charging infrastructure that they need, basically, let's just say it's more on a small scale level. However, if it gets without rebates, grants, and incentives, I can do large scale level because the money is available. So the recommended amounts may be different depending on what type of money that we can get when it comes to the design. So that's where kind of the game is as well, that we would be able to support and help for ensuring that we're having the right station designs, and of course we're not oversizing our systems, and of course getting them as much money as possible for our needs. This is kind of what I mentioned earlier. So we can do full scale charging station design for fleets or whatever vehicles. I would say many different various type of vehicle types, and so we can essentially do the predictive analytics on how long it will take for specific vehicles. Any specific vehicle, we can break it down and get an accurate time frame for the duration of the charging time. Kind of talked about this. There's many different rebate grants and incentives. And so as Ron mentioned earlier, there's a program called the NEVI program. And this is the main fast charger corridor project across the country. So this program is mainly like, how can I have many different fast chargers across the United States? So now we can have reliable infrastructure to travel with electrical vehicles. Because if people on this call that have EVs, I think range anxiety is almost, unfortunately, hopefully not too common, but it's definitely a thing for long trips. And so, of course, having a charged car, if you're traveling and you have an electric car, it's almost, you have to be strategic on how far you can go, just based upon the availability of different charging stations throughout your routes. So part of this program, the goal of the federal program, is to essentially alleviate that. And so we can have multiple fast charger, reliable fast charger infrastructure across the country, so we can essentially increase the adoption rate to become electric. So this is in California, but every state has their own unique program. And you would think hey, California may be ahead of the curve when it comes to the energy side of things. But ironically, we're not the state that has the most amount of money. So it's variable between state by state. And that information, Texas has the most available funding for this program. So of course, right now, Colorado is open. We're working with the state of Colorado right now on a couple of these projects. And I think they're one of the few that is available, but a lot of the other states are coming out with goals on when they're going to launch it. However, in Colorado, we have a month window. So that's the thing. It's important to know that whatever our goals are, because I know these things are investment, high investment type of projects. And that's why I also say, I guess, support, promote ourselves, where it's important to work with a firm that can be on top of it and you can rely on, when the right windows are for us to get this money to reduce my investment costs. Because if we miss it, we could wait another year, 2 years, or we could totally miss out entirely. So part of this program is to kind of show it's like you get the minimum is quantity for 150 kilowatt fast chargers, minimum of 150 kilowatts per each site. And so the grants are available for 80% of the funding. 20% of the funding has to be either essentially up to the other entity to figure out where to get that extra money. That's where I say there's a lot of strategies and how, working with us, little selling point, we can essentially, make sure that we try to find extra funding to get to that 20% to make it a cash flow positive investment for these type of projects. Okay, and so there's going to be many different years of budgeting and I think there's like a 5-year plan for most states. And so they have different funding levels available for specific years. And of course, that's where it's like, if we do miss 1 year, it's not the end of the world, but of course it's going to get more and more competitive as this becomes more and more popular. That's why it's really important to get in there somewhat early. Okay, getting more on the product side. Ron, as before I get more into the product aspect, any questions or comments or anything?
No, I think, the big one, I want to encourage everyone to ask questions. I've already followed up with Casey from Barclays, and Corbin and Casey are going to, hopefully, Casey, you can schedule a time later this week. And that's a perfect example. Again, Barclays is a major global financial institution, lots of different facilities. What works, let's say, I know Barclays got a huge credit card operation in Delaware, might be different from your offices in New York City. And again, Corbin can take you through that. So why don't you keep going, and we're finishing up. Just to frame this a little bit from another perspective, one of the good things about Corbin is our ability to design these projects, customize things, work on the grant side. We're going to hear from a couple other speakers who have more turnkey kind of projects. And again, Corbin can help install them. They could do it separately, because you always need lots of other equipment that Sonepar could provide. And what we're trying to do is give you insights, and we're going to get into the technology, but we also know people are very concerned about the business model as well. All right, let's go, Corbin. We appreciate this. We get another 5-10 minutes.
Absolutely. Level 2 is level 3s. And so level 2s are these are more kind of like a standardized type of charging stations. They're usually around like 7 kilowatts on average. And so that will average around a 4 to 6 hour charge time frame. Significantly less of an investment compared to the fast chargers. Level 2s will average around, like, let's just say $10,000 or less. It's pretty standard. Almost all vehicles can charge from level 2 chargers. However, they are AC, which means alternate current in the electrical world. So there is to charge cars, it has to be converted back to DC. So you're actually going to be receiving less power than that 7 kilowatts that you think. In the fast chargers, there's a wide variety, all the way up from 24 kilowatts to 350 kilowatts. There's going to be, of course, as this market matures, there's going to be higher kilowatt, higher output charging stations that are available. And so the interesting thing, so I mentioned before, and I started the presentation, there's a unique charging standards that's questionable right now when it comes to the fast chargers. So there's a CHAdeMO connector. There's a CCS connector, and then Tesla is also trying to implement their own connecting standards. So what that means is just the connector on essentially the cord that you can basically connect to your car, essentially, to start charging your car. So over the last couple of years, CHAdeMO CHAdeMO connector type was very popular in Teslas, was all Teslas. Teslas had adapters for CHAdeMOs. And a lot of Asian car manufacturers were CHAdeMO. Over the last couple of years, there's been an adoption more towards CCS connectors. And CCS connectors have always been, in the past, American manufacturers and European manufacturers. And so now the tide has been that we're going to be starting to adopt to CCS connector types. And so the grants, the rebate programs, like that NEVI program that I just showed, is a CCS charging standard, essentially, mainly. So that kind of shows too, like where our market is heading towards. And Teslas also have, so now Teslas are being more adaptive to be able to have the ability to charge by CCS connector types as well. So there is a little dance into which connector types that we should provide, but it seems like the CCS connector type now in the fast charger world is starting to get more positive momentum that is out there. Okay, so level 2s. So just think of like longer. So level 2s mainly is going to be like longer dwell times. So if I have a lot of time to spend and charge, level 2s are going to be our best option. So of course, kind of think about use cases like hotels, movie theaters, residential applications like parking garages. You see one of our projects on the top left. Schools. So of course, people at schools are going to be there for a while. Theme parks, shopping centers. So anything where it's going to be, again, 4 to 6 hour charge time frame, level 2s are a great option. And this kind of talks more about the more semantics. There's mounting options, either pedestal by a pole or by a wall mount. And of course, there's access control. So you don't want anyone just to say, if you have no access control, let's just say you have it for your workplace, anyone can try to find that charging station and steal your electricity. So I would always say it's very, very important to try to have some kind of access control. Software is the best option. There's many different values that come with that software. You can actually program it where you can upcharge the cost of electricity and make a revenue off of that electricity that you have. And then also there's RFID card access as well, if that would be of value. So customers can have like let's say a corporate environment. I only want these people. If you want to use our charging stations, here's some RFID cards to go to use the charging station. I do advise randomly last year or late 21, it's 2023 now, right? That California actually updated their code, just out of the blue, and said that like every charging station that's public facing has to have a credit card reader and a screen. And that was one of the new codes that was released. And so the sentiment is that this code is going to be adopted throughout the entire country. So just a heads up when we're actually trying to choose which charging stations are the best for our use case. Here's a couple of examples of what these charging stations look like on the level 2 side, a couple of manufacturers. There's essentially charging stations that are more just, let's just say, more on a functional basis, just plug and give me electricity. And these are what they look like. And of course, just having that capability, the price point is on the lower side. You can get a good charger for like $1,200 to $2,500. Siemens has got a good unit. And here's one without a screen. They're around $2,000 to $4,000. BTC, very credible manufacturer, been around for 2009, 2010. Has a lot of Electrify America contracts. Very reliable unit. These things do not break. That's for dang sure. Price points around $6,000. Have a screen. Have a credit card reader. ABB, one of our core partners, are just coming out with their level 2s. It comes with all the bells and whistles, but also a very competitive price point, a very reliable service from a reliable manufacturer. $2,000 to $3,500. Of course, ChargePoint. ChargePoint's done a great job in marketing themselves, and they're more of they have the higher price point, and they provide a lot of the software and the hardware together, and you can get a charging station unit for around $9,000 to $14,000. And there's also fleet level 2s, which are it's almost double the amount of power, AC power. So again, there's going to be around a 15 to 20% power loss to get it back to the DC level for the actual car. Fast chargers. And so here are the fast chargers that are going to be more towards the more adaptive for us. The more fast chargers that are available, the faster we're all going to adopt to EV charging stations or electric vehicles, I should say. And so a lot of the growth depends on how many fast chargers we can get on the market. So these ones can essentially charge our car from 5 minutes all the way up to like an hour, depending on the power outputs that we want to be able to have for our charging stations. And so kind of verticals, kind of ideas, fueling stations. So, rest stops, gas stations. We're going to have these fast chargers there. Highway corridor projects. Same thing with schools. A lot of, school buses, it's more, sometimes you get larger vehicles, heavier duty vehicles. You need more of a higher power charging station to basically service those big batteries inside those cars. Car dealerships, of course, they need to have those chargers available for when they're basically doing test drives along for their cars. Convenience centers, transportation authorities. And so, very wide range of price point. So, of course, these things are a lot more of an investment. And this is where that design is very important to ensure that we know we're getting exactly what we need so we're not overspending. So a price point can range from $15,000 to $230,000. So of course it's high investment. We talked a little bit about the CCS and the CHAdeMO earlier. A lot of the manufacturers in the fast charger market that have really made their names are ABB, BTC Power, Tesla, and Tritium. So here's an example. I have a 24 kilowatt charging station. We're one of the only stocking partners that stock fast chargers, I believe, in North America, and I think the world. So one of the units that we do stock. 24 kilowatts. Again, what's difference between the DC, of course, it's that amount of power is going to go right to your vehicle. So you're going to get 24 kilowatts. DC power goes into the DC battery. So it's instant power conversion absorption. So this is going to be around $15,000 to $20,000. This was mainly the flagship fast charger, one of the most popular ones when the fast chargers first started becoming released. The 50 kilowatt, and these are around a 30-minute to 1 hour charge time frame, and they can go from anywhere from $40,000 to $45,000. These products are awesome. This is one of the first of its kind that was released last year that you can have a dual fast charger. So we have this 184 kilowatt charger. You divide it by 2, we get 90 kilowatts worth of juice for each vehicle that is charging. And these ones can range from $85,000 for 124 kilowatt all the way up to $110,000 for 180 kilowatt. And these ones you don't need special separate power cabinets. You have the post and all the electrical infrastructure is inside that post out of power cabinet, which is pretty cool. Here's a lot of the bus charging stations, where it's like starting to slowly come out of these pantographs where a bus can pull up and these metal arms connect to the top of the bus, which is really cool, and just start charging instantaneously. That bus driver doesn't have to get out of their car to do anything to start initiating that charging session. We've got a lot of success with this charging station for fleets. So how this one works, you have sequential charging with one power cabinet. And so how it would work is one bus gets 150 kilowatts. Then when that one is done, the second bus gets 150 kilowatts. And then when that is finished, the next bus gets that 150 kilowatts. But of course, if you have 3 power cabinets for this configuration, each bus will get that 150 kilowatts worth of juice. And here's the high power one, the 350. So of course, with this kind of high power infrastructure, we definitely are going to need to have those power cabinets. So how this would work is like one power cabinet is going to be around 175 kilowatts. But if we have 2 of them, one of those charging posts that we see right there will receive that 350 kilowatts worth of juice. It's a 5 to 15 minute charge time frame, and these are expensive, around like $230,000 a pop. Software. So the benefits of software mainly is, of course, access control. You can do strategic programming on who's able to utilize your vehicle. You can control the power. So you can take a dashboard and a screen and just toggle the power output that you want, or how much power you want your charging stations to utilize. You can make a revenue off of electricity. So you can say, hey, if it's 14 cents a kilowatt hour, I'm going to charge 22 cents a kilowatt hour. You absolutely can do that with software. And also having that software also connects you to the apps. So of course, a lot of the main questions is, if I invest into this and I'm trying to have people come to my stations, how do they know about it? The apps. And so people that are EV drivers have multiple apps, and they'll be able to see your charging stations through these applications. I know we're running out of time here, but I just want to include this battery storage just real quick, is that, a lot of the power infrastructure needs that are, if there's any power capacity issues that are available, battery storage are essentially the answer. So we have all that power reserved for our charging stations. And of course, this is what it looks like. And for us, we have been able to provide a full turnkey solution for these battery systems, HVAC, fire codes, the inverters, everything, and you name it. And that should pretty much be it. So